أيقنت أن عزيمتها طريق نجاحها، زاد وعيها، عرفت وجهتها، آمنت بقيمة الفرق اللي تصنع، طموحة، تعلمت مهارات المستقبل، وعدت مجتمعها بعطاء رقمي ما لا حد، حتى صارت مناطق تقنية تلهم كل رائدة وتساعدها تشوف أحلامها. قائدة ما سمحت لشيء يوقفها، هي نور اليوم وأمل، هي انعكاس مستقبل.
السلام عليكم ورحمة الله وبركاته. أرحب بالحضور في اليوم الخامس في ملتقى المرأة في علم البيانات. ملتقى اليوم راح يكون من الساعة 7:30 إلى 8:30، وأولى فقراتنا مع الأستاذة صبا الملغوث، وراح تلقي بإذن الله محاضرة بعنوان تحليل البيانات ودورها في التحول الرقمي. بعد ذلك نلتقي بالمهندسة أميرة علي محسن، وراح تلقي بإذن الله محاضرة بعنوان رحلتي مع علوم البيانات. ونبدأ الآن مع أستاذة صبا الملغوث. صبا الملغوث هي عضوة في مجلس التنفيذي لجمعية مهندسي البترول، وموظفة في شركة أرامكو السعودية قسم التحول الرقمي، وسفيرة الملتقى للمنطقة الشرقية. نبدأ بسم الله. تفضلي أستاذة صبا.
شكرا أخت معالي. ضيوفنا الكرام، السلام عليكم ورحمة الله وبركاته. يشرفني ويسعدني نكون معكم اليوم في الجولة الخامسة من الملتقى المرأة في علوم البيانات. جولتنا اليوم من المنطقة الشرقية بعنوان دور العلوم البيانات في صناعة النفط. نبذة بسيطة عني. صبا الملغوث سفيرة الملتقى للمنطقة الشرقية، من ضمنها فعالياتنا لليوم. عضو في المجلس التنفيذي لجمعية مهندسي البترول في قسم المملكة العربية السعودية، وموظفة شركة أرامكو السعودية في قسم التحول الرقمي. أحمل شهادة الماجستير في سوفتوير انجينيرينج من بن ستيت، وشهادة البكالوريوس من جامعة محمد بن فهد في الشرقية. نحن جمعية مهندسي البترول في المملكة العربية السعودية فخورون بدعمنا لهذا الملتقى، ونتشرف اليوم بنشر بعض من خبراتنا في علوم البيانات والطاقة والبترول معي أنا ومع الأخت أميرة. راح أعطيكم نبذة بسيطة عن جمعية مهندسي البترول. هي أحد أكبر وأهم الجمعيات المهنية في العالم، لها ما يقارب 205 قسم في العالم في 154 دولة، ويصل عدد أعضائها في العالم إلى ما يقارب 160 ألف عضو. تأسست جمعية مهندسي البترول قسم المملكة العربية السعودية في عام 1959، وهي ثاني أكبر وأهم قسم للجمعية خارج الولايات المتحدة. تهدف الجمعية إلى تبادل المعرفة وتقوية التواصل المهني بين أعضائها في القطاع الصناعي والهندسي. أستسمحكم بإكمال العرض باللغة الإنجليزية، وأستقبل جميع أسئلتكم واستفساراتكم بعد انتهاء العرض. The purpose of this presentation is to show the journey of data in the oil business. It's also demonstrating high-level process of the oil journey from exploration to supply chain. This presentation will be an introductory level for any petroleum or geologist experts attending this session. We have been hearing for the past few days from our speakers in this event that data is the new oil. It's true, but let me take you through how oil business was discovered by data. The oil discovery journey started back in 1880s when US geologists discovered the oil fields in USA. Slowly, similar discoveries happened in South America, Asia, and eventually Gulf area. When British geologists discovered in Bahrain oil in Bahrain, they collected rocks, maps, sand, and soil samples from Bahrain to find a match for it in Saudi Arabia. After years of searching, and trying to find similar land features from Bahrain in Saudi Arabia, geologists found oil in well number 7, also known as Bir al-Khair, located in Dhahan. Scientists in 1938 used rock data to find oil. So the oil data journey started with rock samples that traveled the world with scientists to find a match for them in Asia, Africa, and eventually in the Middle East in the 1940s. In the 1980s, oil companies upgraded their systems to an internet and data centers. And in the 2000s, oil companies started using real-time transmissions and smart gadgets to record whatever the well information sent to the data centers. And this is less than 4 seconds. You can see here from the timeline, almost 100 years of collecting data eventually started with rocks all the way to data. So we moved from archiving oil production data to producing oil using data. Key priorities in the oil business depends on many aspects, such as safety, environment, health, optimizing operation, and creating value. To measure if we are achieving these key priorities, we use data to support each stage of the oil production process, starting from exploration, well development, oil transportation, and supply chain. Starting with exploration, which is a tanqib, in order to determine if the area has oil reserves, geologists study the subsurface layers of the earth. They use seismic wave, which is very similar to the X-ray that we are using in the hospital, to know the different layers, also known as formation, and to find oil. These data waves are saved in tapes, as you can see here in the presentation, and then transported manually to the offices to be analyzed. This is the conventional way. With introducing Internet of Things and 5G, these seismic waves will be sent through satellites carrying these images all the way to a scientist's office to analyze it within seconds. Engineers then use high computing mechanisms to analyze and simulate the data to have 3D models of the scanned area. This helps the engineers in aggregating the data and select the best possible location. And here comes the drilling engineer's job. Internet of Things proves to help enhance efficiency of drilling jobs. When engineers start to drill, it leads to a potential danger situations. They basically start drilling in a dark area, depending on aggregated data. The use of Internet of Things devices are beneficial to minimizing risk. Smart devices alert the engineers in advance about drilling errors using data received from the sensors. Engineers and the depth, just to give you, to simulate how deep we go with the drilling and how we go with the sensors. The depth of a well can go as tall as 10 Empire State Buildings. Imagine how many IoT devices are working underground to collect all of these data and send it to the offices within seconds. Engineers and computer science role starts here, where they develop a new solution using multi-data sources to eliminate safety issues, produce more oil, and in a very fast time. One of the new trends in the digital oil business is digital twin. Oil and gas companies are increasingly using the technology to bring well information from multiple sources together in a single and secure place, also known in technology as data lake. So all these connected to analytical platforms and visualization platforms that help visualize and produce the well in real time during operation phase. Digital twin technology results in quick, better well design, improve project delivery, efficiency, and operate in a safety mode. So let me simplify it in a structure that we actually understand. We all use YouTube, and we know how YouTube is built on an algorithm that recommends for you videos after video after video. So basically, YouTube manages to collect all of these databases from your history. These are millions of data going to your history, which is thousands of data, and identifying data features in your videos, knowing what is interesting you in terms of this kind of video or others. Then provide a recommendation system and prioritization system for that video. Similarly, we have it in the well delivery. So how can we make our wells smarter? Is by learning from our history and building solutions on top of it. So the well system access databases, analyzes well production history and behavior to help recommend production forecasting and eventually having the well itself understand what to do next. So this is what we aspire to have, an autopilot well. So another use of IoT and data is in refineries and supply chain. I'll give you a brief of it, of where we use it exactly. So IoT can help monitor things like pipeline pressure, oil flow meter, among other of the performance parameters. A lot of these measurements and data is required regarding every component, and it's very critical and the refinery team need to have updated numbers and rates about each equipment in the refinery. And this actually enables manual work where you need to send humans, workers to small and dangerous places in the refinery to check if this gadget or this rate test is actually accurate. So here we introduce the IoT. Some areas, as mentioned, are in a very small and we cannot reach it. So we use real-time data transmission. IoT allows more data collection accuracy, and it helps eliminating danger for our human resources in terms of the field development. For the supply chain, the oil and gas industry has faced the problem of inventory planning and optimizing. IoT help in efficient planning and scheduling in the supply chain process. Refineries can use sensors to detect the blend of crude oil incoming to extract from the exact location, meaning the well, to the barrel. So we can monitor the first drop of the oil in the well all the way to the ships that is actually transferring and exporting these oil barrels to the world. So the use of IoT here in the supply chain management helps in transparency and accuracy to have an accurate time and schedule for delivery. So another aspect of data is using it in safety and training. So we saw it in the previous examples where we went from exploration, field development, where we actually drilled for the well, developed the well, and then produced from that well. We went furthermore to the refineries where we store the oil and then export it to our to sellers. So this process is bound with a chain, which is data. And this helps a lot in terms of analyzing and capitalizing on any kind of valuable data. And this is where one of the major oil company chief of information technology, Mr. Sandbit, said data is king, and one of the most valuable resources. You cannot avoid data. You cannot say that there is an expiration date for the data. There isn't any expiration date. Any history data is helpful for any future or forecasting projects. Now, when it comes to safety, we actually capitalize on existing and old, or we can say past data to develop scenarios. Let me give you one scenario. For training, we train our drilling and maintenance engineers similarly to the airplane pilots. They need to go through hours and hours of simulation training and tests to be prepared for a drilling job, as it is one of the dangerous tasks in that chain. Using history data helps in building scenarios to test the engineers, and eventually we are planning to build an AI model where it will understand and predict future issues that can a drill engineer be prepared for it in a simulation environment. The other thing that we are using data here is for the GIS data, which is the map data. Companies are before they drill a well or before they select an area to be to start exploration in it, they need to know that it's a safe area. And here the companies are relying on the government to get all the needed documents and plans for that area, which is for us in Saudi Arabia, البلدية أو الأمانة. This helps in forecasting where we want to allocate a well in an area that is far from residency area and from hospitals or any kind of crowd area. This is a safety measure, and we need to do that with each new well or each field that we have in the world. So this one of the major components of it is the GIS maps. So let me just go through this really fast. So we'll develop exploration, starting with exploration. Years and years ago, this was an 18 months process. With data and with digital transformation and with technology, it's now almost about 6 months to get seismic data available in the desktop of the scientists to be interpreted and to be used for field development. For the well development, it used to take 4 to 5 years to build, to construct, and to drill a well. Now it's almost 18 months with the new technologies. And similarly with the other aspects, such as transportation and the refinery, it started with 6 to 12 months, and now we can have it in less than 25 days. Exporting with using smart gadgets that actually trace the ships, the goods that goes from one point to another. It was up to months, now it's up to days. So this shows you how data is actually aggregating and helping in expediting oil exporting. So for now, I finished the part where we talk about data and how it's showed and used in the oil sector. I would like to actually grab your attention to SPE, Site of Petroleum Engineering online platforms. One of the good things that we have in our society is actually bringing online courses for data science and engineering analytics. These are very beneficial if you are an engineer or you are a computer scientist and you would like to explore the energy sector. This is the one stop for you to help you in terms of online education for oil and gas. And again, I'm from the SPE KSA section, and we would love and we are happy to have you joining our team, joining our platforms. We actually have a lot of online, during this COVID-19, we have a lot of online webinars that brings technology, energy, and development all in one place. So you can follow us in SPE KSA on our social medias, and I'm open now for any questions.
الله يعطيك العافية أستاذة صبا. شكرا على هذا الطرح شكرا على هذه المعلومات القيمة. راح أطرح عليك بعض أسئلة المتابعين. هل علوم البترول صعبة على المبرمج؟
لا، للأمانة يعني أنا خلفيتي كلها في الكمبيوتر ساينس وفي السوفت وير انجينيرنج، واللي أشتغل بشركة أرامكو السعودية 8 سنوات، والحمد لله يعني ماشي حالي. لا بالعكس، it's actually a science that improves your skills.
هل علماء البترول يستخدمون بيانات عمرها فوق 60 سنة؟
نعم، وذكرت في البرزنتيشن أن البيانات ما لها expiration date. نعم، هي يمكن تتغير كفيتشرز، ولكن كاستخدام إلا ما نرجع للهيستوري عشان we build عليها ال current situation و forecasting the future. It's very similar للميثودولوجي حقت يوتيوب. They know your history. When they know your history, they can recommend new videos for you. And that's why big data and again, the data science work starts from there, where you actually go and investigate the history and produce the future.
الله يعطيك العافية. هل ال IoT مفهوم جديد على علم البترول؟
أبدا لا. IoT مر بمراحل مختلفة في علوم البترول. في بداياتها كانت في الثمانينات، إذا ما كان حتى قبل بعد. كانوا يحطون devices gadgets على الويلز نفسها، على الويل هيد، على البلاتفورم حق الدريلينج عشان ياخذ المعلومات. هذه زي كأنك قاعد تسجل لك المعلومات، وراح تحط لك اياها بعدين ريكوردد، ويجي بعدين الانجينير والساينتست ياخذوها في مكاتبهم ويشتغلوا عليها. طبعا مفهومها السابق هي شيء ستاتيك في مكانه. المفهوم الجديد اللي حاليا احنا قاعدين نستخدمه، basically استخدمنا هذه الريكوردرز بانها اضفنا عليها الترانسميشنز where it can transmit itself the data from one point to another. It goes automatically to the engineer's office.
طيب شكرا. سؤال أخير، كم سعة أشرطة مسح الأرض؟
سعة أشرطة مسح الأرض على حد علمي، وما أبغى أفتي فيها، طبعا هي القديمة اللي كانوا يستخدمونها أو تقريبا للحين يستخدمونها it can go up to 4 تيرابايت. فمن هذه من أسبابها استخدامهم حاليا للساتلايت ايميجينج في نقل المعلومات، لأنها حاليا ثقيلة على يعني في نقلها من جراوند إلى ساتلايت إلى الأوفيس بهذه السعة، بسعة 4 to 7 تيرابايت.
أوكي، عندنا سؤال من what about AI and when and how we can use it in energy data?
So AI is a stage where you can يعني AI comes at the last stage where you have already built your data, when you aggregated the data, and you have built platforms, analytical platforms عليها. Eventually, you will have these data can build a machine learning. It can be learned by itself and diverse to artificial intelligence. And artificial intelligence, as we know, it's a state that it's already self-developed. It's a state that will learn from all of the data that we have and build on it in the future. Where I can see AI, I can see it in a lot of stages in our oil and gas process. We can see it in equipment failures. We can predict equipment failures, and if we can predict it, we can have a solution for it ahead of time.
Okay. طب عندنا برضه هنا سؤال: which program do you use for data analysis?
Depending, it depends on what are you doing with data analysis. If you're only viewing a visualization, well, for visualization, Spotify, Tableau, يعني in terms of visualization.
الله يعطيك العافية دكتورة. هذه هي الأسئلة. راح ننتقل الآن إلى المحاضرة الثانية بعنوان رحلتي مع علوم البيانات مع الأستاذة أميرة علي محسن. هي مهندسة بترول ومديرة التحول الرقمي بشركة شلومبرغير السعودية. انطلقت مسيرتها المهنية بالحقول النفطية في سلطنة عمان، وتلتها العديد من المناصب الأخرى، عضو في جمعية مهندسي البترول والميكانيكا. كيف حالك أستاذة؟
الحمد لله ويعطيك العافية معالي، والسلام
تفضل.
عليكم، وشكرا لاستضافتكم وشكرا لحضوركم. إن شاء الله تكون جلسة خفيفة عن علم البيانات ومراحلها ودورها في النفط والغاز. اللي عنده أي سؤال أو استفسار إن شاء الله بجاوبها نهاية البرزنتيشن. فببدأ معاكم إن شاء الله. اسمي أميرة علي محسن، مهندسة في شلومبرغير، مديرة قسم الديجيتال ترانسفورميشن. التحقت بشلومبرغير في عام 2015 مباشرة بعد تخرجي من جامعة سالفورد مانشستر، تخصص هندسة بترول وميكانيكا، والآن تقريبا بكمل 5 سنوات في شلومبرغير. في هالفترة مريت في مناصب وأشغال مختلفة في أكثر من دولة، وكان لكل شغل تحدي وطعم خاص. اليوم أنا بتكلم عن رحلتي في علم البيانات والمعلومات الرقمية، وكيف زاد شغفي كل ما تعمقت في المجال. بسم الله الرحمن الرحيم. Data is the lifeblood of our industry, so it penetrates everything we do. It represents itself as a competitive edge for all operators and service companies. So much of it is produced every single day, yet so much of it is not consumed, processed, or used to create insights for a leap in operational performance. So the opportunity is huge, especially when we consider the advances of data analytics, science, and AI, and the benefits other industries have realized when using data revolution. So the process from converting data to information to knowledge happens on a daily basis. I'm sure we all do it. Decisions that would affect our performance as a company or as an industry in the oil and gas rely so much on data, making it our differentiator and our core of profitability. The oil industry recognizes that great power and eminent breakthroughs can be found in this data by using it in smarter but faster ways. However, how does the industry bridge the vocabulary and cultural gap between data scientists and technical petroleum professionals? Despite its astronomical revenues, the profit margin of the oil and gas majors, believe it or not, is 8 to 9%. Finding and developing oil and gas while reducing the safety risk and environmental impact is difficult. Because why? We have a couple of reasons in front of it that consume money but also produce data. First, oil is hard to find. Reservoirs are generally 5,000 to 35,000 feet below the earth, resulting in operational and technical complexities. Second, oil is expensive to produce. The large amount of science, machinery, and manpower required to produce a barrel of oil must be done profitably, taking into account cost, quantity, and market availability. And 3, drilling for oil presents potential environmental and human safety concerns that must be addressed. Finding and producing oil involves many specialized scientific domains, such as geophysics, geology, and engineering, where each has a unique recipe for getting the most out of the ground profitably and safety. So the integration and mining of data formed in the hydrocarbon finding and producing process offers amazing potential for answering some of the biggest questions facing the oil industry. The biggest question, where is more oil? The next biggest question, how do we get substantially more out of the ground safely with a minimal environmental impact? And the less desirable but possibly most relevant question is, how do we use data that has such potential to unlock these answers? So, data science will help the oil and gas industry learn more about each reservoir and inject more accuracy and confidence in every decision, ultimately reducing the risk involved. So in order to uncover useful intelligence for their organizations, data scientists must master the full spectrum of data science lifecycle and possess a level of flexibility and understanding to maximize returns at each phase of the process. So the chart here in front of you represents the 5 stages of the data science lifecycle. We start with the data capture or the data acquisition. How do we get the data? Then you move on into maintaining the data, cleansing the data, staging the data. Then we go into processing the data, which is more about data mining, data classification, data modeling. And then we analyze the data. Actually, this is my favorite part, which is we use the predictive analysis, regression, text mining in order to do what? In order to communicate the data, to visualize it, as Siba mentioned, through Spotfire and so on, through to give us business intelligence to make informed decision-making. This is the end goal, informed decision-making. I was fortunate enough to work or take up roles in all phases of the data science lifecycle. So you'll see my pictures throughout the lifecycle, and I'll start with the data acquisition or capturing. I started my career as a wireline field engineer in the deserts of Oman. Wireline is a service where data is acquired for reservoir or hydrocarbon evaluation through cutting-edge technology or tools. These tools acquire numerous data types depending on various scientific computations and physics, including petrophysical, sonic, production, pressure data. And the really interesting thing is it is transmitted real time. So you see the data flowing from the wellbore to our processing decks or computers. If you see here on the right, there's a tiny truck. This is actually my office. The data is acquired. The data acquired could be 20,000 feet below sea level, resulting in operational complexity and data intricacies. Therefore, we use several QA/QC techniques to ensure the integrity of the data or logs, a process called data validation. And what do I mean by logs? It's the middle picture you see in the slide. One thing I would like to highlight, dealing with hydrocarbon data meant dealing with million-dollar decisions that are based solely on data, validating the fact that data is the lifeblood of this industry. And that led me to the first lesson learned. Data quality is key. The quality of the data will help you make the judgment with greater certainty of whether or not hydrocarbons are present. If the data looks promising, the company can continue on and complete the well. However, if the well is not promising, the process can be halted and the well abandoned before incurring the additional cost of completing the well. And just to give you a rough estimate, completion has an average cost of $1 million per well. So I'll move on to the second stage, which is the maintaining phase and the most time consuming. In 2018, I moved to Saudi Arabia as a borehole production engineer. And I would like to highlight the picture on the right is pre-COVID-19. So stay safe, guys. So I was basically moving from acquiring the data to processing or cleaning it for real-time decisions. The process includes unique approaches to identifying bad data and validating data accuracy for interpretations. The data is used for fast decisions and business intelligence for critical procedures or services done on the wellbore or casings. So my work during the time allowed me to understand or realize the second lesson. Data accuracy is crucial. for informed business decision. This step of the process is most important because it will allow you to eliminate inconsistencies, misspelling, different cases, upper and lower letters, and most importantly, identifying missing data. This is just a subset of example where you can see inconsistencies, and it's important to catch and fix them in this stage before building your model. So I'll move on to the next phase of the data science lifecycle, which includes the data processing through classification. This is where you understand the patterns and bias in your data. It could involve pulling up and analyzing a random subset of the data, plotting a histogram or distribution curve to see the general trend, or even creating an interactive visualization that lets you dive down into each data point and explore the story behind the outliers. The outliers are data that doesn't fit into the overall trend of the data you have. So using all of this information, you start to form a hypothesis about your data and the problem you are tackling. It allowed me to understand each piece of the data tells a story that fits a bigger picture. And moving to the data analysis, where it involves predictive analysis and text mining, which is the most challenging yet fun part or phase of the data science lifecycle. During this stage of my career, I was working in several projects that involves data-driven decision-making. I started working with data around the clock to understand a pattern and predict future outcome. I was completely immersed with data and data analytics. So when we say data analysis, what is data analysis? In simple words, data analysis is the process of collecting and organizing data in order to draw helpful conclusions from it. The process of data analysis uses analytical and logical reasoning to gain information from the data. So the main purpose of the data analysis is to find meaning in data. Here are the 4 types of data analysis. So I'll start with the past aspect of the data analysis. First, I'll start with descriptive analysis. Descriptive analysis looks at past data and tells what happened. This is often used when tracking key performance indicators, revenue, sales lead, and more. Then you have diagnostic analysis, which aims to determine why something has happened. Once your descriptive analysis shows that something negative or positive happened, diagnostic analysis can be done to figure out the reason. Then moving on to the future aspect of the data analysis, which is predictive analysis. It predicts what is likely to happen in the future. In this type of research, trends are derived from past data. So it validates that any data is good data, which are then used to form predictions about the future. Lastly, I'll go on to prescriptive analysis, which combines the information found from the previous 3 data types that I talked about and forms a plan of action for the organization. This is where the data-driven choices that we talked about are made. If we dive into predictive analysis, there are several types of that will allow you to reach your end goal. Just talking generically, predictive modeling is where machine learning finally comes into your data science project. It uses comprehensive statistical methods and tests to ensure that outcomes from the model actually make sense and are significant. This is where you decide which model to pick for your problem. This is never an easy decision, and there is no single right answer. So data scientists out there, remember that there is no single right answer. The model will be dependent on the size, type, and quality of your data. How much time and computational resources are you willing to invest, and the type of output you intend to derive. But a type of data that most organizations neglect during the analysis phase, or even throughout the life cycle that we talked about, it is the unstructured data. unstructured data is data that doesn't have a recognizable structure, which includes text files, photos, web pages, and blog posts and presentation. The bulk of data generated today is unstructured data. So it is important that organizations find ways to manage and analyze it. With the evolvement of technology and artificial intelligence, algorithms now can help extract meaning automatically from the volumes of unstructured data that is created on a daily basis. With the ability to quickly scan huge data sets and find different patterns in customer behavior or consumers, decision makers learn what products or services are most compelling for their target market. This has important applications for product development, as well as figuring out what market initiatives are most worthwhile. And then I'll move on to the last phase of the process, which is data visualization. Data visualization is a tricky field, mostly because it seems simple, but it could be possibly one of the hardest things to do well. That's because data visualization combines the fields of communication, psychology, statistics, and art with an ultimate goal of communicating the data in simple yet effective and visually pleasing way. Once you derived the intended insights from your model, you have to represent them in a way that different key stakeholders in the project can understand what are you saying with the data. So I'll just show you a brief example of one of our applications developed in Schlumberger called Products, which is found in our solution Delphi to communicate, let's say, production data. So what are some of the success or achievements of AI achieved in upstream oil and gas? And I heard a question asked earlier, so that will answer your question. An interesting example is a joint effort between Schlumberger and our client Woodside on the development of highly automated machine learning system that ingests and quality controls all data input. It identifies the bad data that you see here in the middle and predicts the good data in the bad areas. It understands the uncertainty and then creates the best quality logs possible. This algorithm, not optimized, takes about 8 hours to configure and run, versus 4 people working for 4 weeks, giving a 90% accuracy, cutting down weeks to hours. Another example is the use of machine learning for salt picking, cutting down time from weeks, again, to a couple of hours with more than 94% accuracy. And there are many examples to showcase, but I'll move on. But what are the unique challenges that the oil and gas industry experts face? The way we operate is the biggest challenge. The way we operate is usually in silos, where data is stored and not shared across the organizations or teams due to confidentiality, data ownership, and most importantly, most of the data is derived and could be interpreted in several ways, giving many forms of a story. Another aspect is that many of our data is unstructured and most often forgotten to be used for valuable insights and informed business decisions. But due to the exceptional nature of our industry and the data present and acquired, it's very easy to lose focus unless we understand what our objective and main goal is. What are we trying to do? And what business intelligence are we trying to make? The core of data science doesn't concern itself with specific database implementations or programming languages, even if these are essentials to practitioners. The core is the interplay between data content, the goals of a given project, and the data analytic method used to achieve those goals. And I'm very proud to see a strong female presence in the forum or conference. But what's keeping women out of data science? The demand for digital talent is huge and growing so fast. Unfortunately, women constitute only 35% of university graduates in the science, technology, engineering, and math, or the STEM disciplines, but only 25% of the STEM workforce and just 9% of the STEM executive leadership. Adding more women to the digital workforce will do more than just fill a growing need for talent. Companies in which women are equally represented are more innovative and resilient, and women working at them have higher levels of engagement and ambition. I foresee an increase in women presence over the years as more young professionals understand the nature of the work and the benefits on working in technically challenging but very rewarding environments. All things said, we are living in a historic era of an explosive period of growth for the oil and gas industry, mind-boggling growth in both the production of hydrocarbons and digital data. Data science and all the new emerging technologies enable the discovery of new opportunities, generating more efficient workflows, increased safety, and significant reduction in operational costs. As the oil and gas industry grows and becomes more receptive to big data and the use of data science in general, it can only move forward. Huge volumes of unused and undervalued data that is just stores has little worth. For data to be a true asset, it must be identified, aggregated, stored, analyzed, and perfected. The ability to understand insights from large datasets can make the oil and gas industry more profitable and more efficient. So thank you very much, and please let me know if you have any questions.
الله يعطيك العافية.
الله يعافيك.
راح أطرح عليك بعض أسئلة المتابعين. أول سؤال عندنا.
تمام.
If the data is human entered, therefore, the quality is not reliable, and still every bit of the data matter in the petro decision making. As you said, million depended on it. How we can overcome this problem?
So during the process, we used several QA, QC techniques or the data validation, where we understand the accuracy is not there, but we have to test and validate the data throughout the stages of the life cycle to eliminate the outliers that I talked about.
Okay, شكرا. السؤال الثاني, as you mentioned the unique nature of the subsurface data, how we can initiate the process of using data science on the oil and gas industry?
So it starts with openness. We have to liberate the data across the organization. We have to work together, break down silos, and allow to create useful insights from the data itself.
Okay. What is your biggest challenge throughout your journey?
I would say in Saudi Arabia, it's the volume of data. Mashallah, knock on wood, the volume is huge. So going through that amount of data and applying the 5 stages that I talked about is not only time consuming, but technically challenging.
Okay, عندنا سؤال ثاني. How about big data? Is it important?
Of course, especially in the oil and gas industry. So when you start the data mining, the more data, the merrier. So imagine having a pool of data or big data to analyze, to mine, to process. It will not only increase the accuracy of your model, but it will create more reliable and informed business decisions that I kept on stressing throughout the presentation.
الله يعطيك العافية أستاذة أميرة. كان هذا آخر سؤال معنا.
شكراً. الله يخليك.
وهنا تنتهي جولتنا لليوم في المنطقة الشرقية. وكان عرضنا اليوم عن دور علوم البيانات في صناعة النفط. حابة أشكر طاقم منصة عطاء على جهودهم الجبارة في خلال الأيام اللي فاتت، وجهودهم راح تستمر إن شاء الله معنا لنهاية المؤتمر. حابة بعد أشكر سفيراتنا في المناطق وجهودهم العظيمة في جعل هذا الحدث لأول مرة عندنا بالشرقية. فأشكركم على جهودكم، وإن شاء الله راح تكون ما راح تكون الأخيرة، راح تكون معنا سنين قدام إن شاء الله. وآخر شيء بس حابة أذكر الحاضرين معنا إن بكرة راح نرجع لعلوم البيانات والصحة وإدارة الأعمال، فلا تفوتكم السيشنز اللي بتكون موجودة إن شاء الله. ويعطيكم العافية جميعاً.